Hello everybody, this is Yunhao, and today we're going to introduce our group's project, which is machine learning applications in accurate indoor positioning. Our group members are myself, Jiacong, and Huaxia Zhou. First, let me introduce the outline of our project. First, I will introduce the motivation, and then I will introduce a data acquisition and pre-processing method we use in this project. Then introduce the machine learning algorithm. Finally, we will show the result of our comparative experiment. First, let me introduce our motivation. Now, and currently, accurate localization is an essential technique for many applications. For example, the rescue and the traveling navigation. However, the most popular method of localization, which is GPS, Global Positioning System, has a limitation for localizing indoor objects because the building will block the signal from the GPS satellites. So the development of the indoor positioning algorithm has drawn much interest from different researchers and the companies. So in this project, we're going to focus on the machine learning algorithm application on the indoor positioning based on the Wi-Fi fingerprint data. First, I'm going to show the data acquisition. And here is our experiment scenario on the left, which is a living room of a studio. And the blue point represents the sampling positions or the sampling points, which means that we will sample the Wi-Fi fingerprint data on those positions. And the photo on the middle shows the data acquisition setup. You can see here is a Xiaomi mobile phone. And in order to prevent the hand shaking, we place it on a tripod. And the right photo shows the application, the Android mobile application we use for the data acquisition, which is called the get sensor data. And it can create a text file which store the Wi-Fi signal strengths. And here is the data we collected. For pre-processing part, we filter the MAC addresses, which corresponding to the access point, AP. In this case, we filter the MAC addresses which appears on all the sampling positions, which means that these 6 MAC addresses are which can represent the APs which appear on all the sampling points, as you can see here, and the y-axis is the signal intensity, which represent in the -dB. Yeah. And so we use this Wi-Fi signal strength data, which is a 6-dimensional vector as the input of our machine learning algorithm. And here are the algorithms we used, including the linear regression, ridge, and the single layer neural network regression, which is shown here. And also we test a KNN-based classifier and do the comparative experiments. And here is the result. In this project, we use the cumulative distribution function, CDF, to report the error of different regression algorithms. So in this case, if the curve moves toward left, which means that the absolute error becomes smaller, and in this case, the localization precision is higher for this algorithm. So in this graph, we can show that the accuracy of ridge regression and the neural network is higher than the traditional linear regression method. And the performance of the ridge regression and the neural network are similar. From the graph on the right, we can see that the accuracy of the KNN method is higher than the neural network, which indicates that the classification method in this scenario may be more accurate than the neural network-based regression. And here is our conclusion. So the ridge regression and the single layer neural network have a higher speed and better positioning precision, which are better algorithms for wireless indoor positioning. And from the graph we shown before, KNN classifier performs better than the regression-based method. That's I'm going to show today. Thank you very much.